Finding the midpoint between two other points on the Cartesian plane is fairly straightforward. Now, to understand what's going on, it's probably easiest first time around to actually draw the points and then picture how you found the midpoint. Now, if I go along here and graph the point 2, 1 and 6, 8, 3, 4, 5, 6, and let's go up around 8, we'll call this 6, 8. Then to find the midpoint between them, it makes sense that if you were to find the midpoint of a diagonal, then you're basically finding the midpoint vertically of that middle point, and at the same time you're finding the middle of the horizontal. So if you're looking at how far apart these 2 points are horizontally, this one is across at the 2, and this one is across lining up with x equals 6. This triangle is 4 units wide, and so it makes sense the midpoint is going to be across 2 units here at x equals 4. So this point will have the x value of 4 because that's halfway between 2 and 6. And it makes sense also that this point will have the y value that's halfway between the other 2 y values of 1 and 8. So between 1 and 8 we've got a length of 7, and half of 7 is 3.5. So if we find the y value of this point here, which is 1, and go up 3.5, this will be sitting at 4.5. Now, that's the theory. The easiest way to think it through is just what is the average of 2 and 6? And of course, when you average something, you add the two things together and divide by how many there are. And to find the y value, what is the average of 1 and 8? Well, if you add 1 and 8 together and divide by how many things there are, 2, you can find the average that way. Turning this into a formula that you can use quickly and easily every time, if you were to label these points as x1, y1 and x2, y2, then all you've really done here is you've added together your x's, x1 plus x2, and divided by 2 to average them, and then you've added together your 2 y's and divided by 2 to average those. Now, people sometimes get confused with this because they think, well, what about if there's negative numbers involved? Is it still going to work? So let's have a little look at this to check that it will still work when we're using negative numbers. We'll leave our formula there. All right, let's find the the midpoint between, say, -3, -4, and 2, 1. All right, using the formula method, let's try it. Our midpoint equals, let's write midpoint equals, all right, now x1 minus 3 plus the other x is 2. Does it make any difference which order you add them in? Not at all. You're just adding two things. You can go 2 plus -3, which is 2 minus 3, or you can go -3 plus 2. The answer is the same. You'll still get -1 here. And then you need to halve it. And then you need to add together your y values, -4 plus 1. And halve those. Tidying up, we've got -1 over 2, so we've got -1/2. And for the y values, -4 plus 1 is -3, so we've got -3 on 2. And if you wanted to, you could convert that and say, well, that's -1.5 actually, which makes it a little bit easier to plot where it would be on the Cartesian plane. Now, it makes no difference which order you use your x2 and x1 because you're still adding them together and always dividing them by 2. So this formula works. But as with any formula, while it's really handy to memorize it and just apply it, you really need to understand where it comes from so that if you forget this with all of its x's and y's and 1s and 2s and bits and pieces, you understand the concept that we're really just taking the average of the x's to find the x value and the average of the y's to find the y value of the midpoint.